Hello everyone. In this video we're going to learn how to multiply polynomials. We've already covered monomial by monomial multiplication in our previous video, and that's basically a polynomial with just one term times another polynomial with just one term. So for example, what we see here is an example of one monomial times another. We know that we're just going to multiply the coefficients to get the 21 and multiply the powers of x as long as they have the same base, and use the product rule so that we keep the base and add the exponent. So we get 21x to the 5. So the transition over to monomial times polynomial is also very simple. We're basically going to be utilizing a familiar property from the past, the distributive property. We know that when we have a times b plus c in this manner, or we should say a times quantity b plus c, because these are contained in a group, we're going to be distributing the a into the parentheses, so we get AB plus AC. The full name is the distributive property of multiplication over addition, because it's the first property that connects the two operations together. Before that, we had like commutative property for addition and multiplication. We had the associative property for addition and multiplication, but both of those sets of rules only dealt with one operation, but the distributive property is the first one that deals with both. And of course, this doesn't just work when the parenthesized portion has two terms. It can have as many terms as we want. So as long as we're dealing with polynomials, we're going to be dealing with a finite number of terms. So we'll just go from t1 to... So in the same manner, we just go ahead and distribute the a into all the terms within the group, and we end up with a times the first term plus a times the second term, etc., all the way to the nth term. So here are a few examples. We can go ahead and put the rule to work. So here, of course, we're going to be distributing this 2x into both of those terms. So we end up with 6x squared, because remember, when you have x times x, that's like x to the 1 times x to the 1, so we get x to the 1 plus 1, which is x squared. Or you can just look at it as the definition of x squared, thinking from right to left, which means x times x. In either way, make sure that you don't make the mistake of just writing 6x, which is a common error. So we get plus 2x times 1, which is just 2x, and we're finished there. So here we're going to be distributing this negative 3x squared y into that group of terms, and we want to be careful when we distribute a negative number. So here we have negative 3 times positive 5, so that's going to give us a negative 15. So we have negative 15. Now the x squared times x cubed is going to give us x to the power of 2 plus 3, or x to the 5. And remember, there's an invisible 1 on that y, so when you multiply y and y squared, we're going to get y to the power of 1 plus 2, which is y cubed. Now we're going to multiply negative 3x squared y by negative 6xy, so we end up with positive, because negative times negative gives us positive 18 x squared, and we have invisible ones on both of those, times x to the 1, so that becomes x to the 2 plus 1, so that's x cubed, and then y to the power of 1 plus 1, which is y squared, And now we have negative times negative once again will give us positive, so plus 15x squared y. Now, if you are comfortable enough with doing it that way and not making errors, that's fine. If you notice that that's keeping track of too many things and you may end up making errors, then just do it in 2 steps. So we are finished with that, but alternatively, you could have just shown the distribution. So you have negative 3x squared y times the first term, and then minus 3x squared y times the second term, and finally minus 3x squared y times the last term, which is negative 5. And then you could just in a more slowed down fashion go from this to that final answer. So if you think that intermediate step helps you, then include it. But if you are comfortable enough to where you can go from this to this result, then you can go ahead and bypass this step. But again, it all depends on your level of comfort. When it comes to situations where fractions involved, I definitely recommend that you show the intermediate step. So here we're going to do that. So we're going to write negative 1/3 y times 6y squared, and then negative 1/3 y times negative 3y, and finally negative 1/3 y times negative 9. So now we go ahead and take care of each of those multiplication problems. So we end up with here we can go ahead and simplify the 3 and the 6 to leave us 2. We'll take care of the sign in the next step. Here both 3's cancel out, and here we have the 3 and the 9 leaving us a 3. So now we'll go ahead to the final step where we have, so we have negative y, and there's a 2, so we get negative 2y to the power of 3. In here we have negative times negative, that's going to turn into a positive, and the only number left is just going to be a 1, so we don't need to write it. So we have y times y, which is y squared. And then here, again, we have negative times negative, so that turns into a positive. And we have 3 times y, so we just write 3y. These are really simple. You just have to really watch the signs, make sure you don't make any careless errors. Again, be sure to practice all of these on your own and be working along with me for maximal benefit. It does not do a lot of good to just watch a math video. You have to learn math by doing it. So next, we're going to look at polynomial by polynomial multiplication. So we're going to have more than one term, such as we see here, by more than one term that we're going to be multiplying. Now, the procedure is going to involve distribution again, but obviously since we have more than one term here that is going to get multiplied, we have more than one distribution going on. So first we're going to distribute 3x in this manner, and then when we're done with that, we're going to distribute the 2. So we get 3x times 2x minus 5 plus 2 times 2x minus 5. So we're distributing each of these sequentially. So now we go ahead and distribute as we normally do. So we get 6x squared minus 15x plus 4x minus 10. So now we notice that we end up with two like terms in the middle here that we can combine. So we end up with the final result of 6x squared minus 11x minus 10. So that's simple enough, and that is how we multiply two polynomials. Of course, either of these two polynomials could have more than one term, in which case we just take the one on the left and we'll just go ahead and distribute each of its terms into the next polynomial. This is just doing it in a classic standard way in a horizontal fashion. We also have a really nice tabular method, which we'll look at in 1 second. Now, we could have done this using a table as well, in exactly the same way that we used to create times tables. So what we do is we'll go ahead and write one of the polynomials that is being multiplied horizontally, and we'll go ahead and write the other one, the terms for each one, we line them up vertically. Makes no difference which one we put where. So we could have put 2x minus 5 here and 3x plus 2 here. Why? Because if you recall, a times b is equal to b times a. That's called the commutative property of multiplication, or multiplicative commutativity. For short. So now we just go ahead and, just like a times table, so we'll go ahead and multiply this by this and write the result here. So 2x times 3x gives us, of course, this silly pop-up. All right, 6x squared, and then 2x times positive 2 will give us positive 4x, and then negative 5 times 3x gives us negative 15x, and negative 5 times positive 2 will give us negative 10. All right, so the nice thing about this table method is that it keeps everything organized, and we're basically going to see all the like terms lined up like that usually, if there are no missing powers. So we notice that, and also it keeps the problem kind of in a finite amount of space. So we can see that the results are of course going to be in this inner part. Those are the original factors that are being multiplied. So we only look in here for the result, and we go ahead and combine like terms. So we end up once again with 6x squared minus 11x minus 10, which is of course the same result we got on the previous page, if you recall. Let's take a look. So doing it in this manner horizontally, we ended up with the same result. The real power of this table method becomes real apparent when we have more than two terms in either of the two polynomials. And as you'll find, I'm a big fan of this method because it's very, very efficient. In reality, you're not doing anything differently. You're first distributing 2x, for example here, and then distributing negative 5. So when we look at it that way, we actually are looking at the multiplication more like this. And you can try it. You can put the 3x plus 2 here and the 2x minus 5 there. You'll see that you'll end up with the same final result because of, once again, multiplicative commutativity. All right, so we're going to go ahead and look at a 2 by 3 now. So you can see that the initial number of terms will be 6 exactly. So you can multiply the number of terms here by the number of terms, because you're going to distribute one term, and then that's going to give you 3 terms, and then the next one when you multiply it, it'll give you 3 other terms. So the initial number of terms is 6. But then there may be some combination possible that would reduce the number of terms. So let's go ahead and multiply this out. I want to show you just the regular horizontal distribution method first. So we have x minus 2 times x squared. Let me leave some space actually. So we have x minus 2 times x squared minus 3x plus 2. So we're going to distribute the x into this group first. So we have x times x squared, so that gives us x cubed. X times negative 3x, that's positive times negative, so it's negative 3x squared. And then x times positive 2 will give us plus 2x. So now we're finished distributing the x. Now we're going to distribute the negative 2. So negative 2 times x squared is going to give us negative 2x squared. I could just keep going horizontally, but better yet, why don't I just write it under this so that they're already grouped together. So since they're going to be like terms, so we have negative 2x squared, and negative 2 times negative 3x is going to give us positive 6x, and negative 2 times positive 2 will give us negative 4. We don't have anything like negative 4, so we'll just write it on the side like that. So now we just draw a line here, and we'll go ahead and combine any like terms. So we have x cubed minus 5x squared plus 8x minus 4. So that will be our final result. Now, we can do this also using the table method. And here, remember, we're just going to take care of this distribution and write the results here. So we have x times x squared, which is x cubed, that'll go here, and then minus 3x squared for x times negative 3x, and then x times positive 2 will give us plus 2x. Here we have negative 2 times x squared, which gives us negative 2x squared. And negative 2 times negative 3x will give us positive 6x. And negative 2 times positive 2 will give us negative 4. Notice that our like terms are nicely grouped here. Those are 2 like terms, and here is another pair of like terms. So now we simply go ahead and write the outcome. So x cubed is just by itself, so it remains. These two add up to negative 5x squared, and these two will combine to give us positive 8x, and then minus 4. So of course we got the same answer as we got before. All right, so that's how you do these. Make sure you can handle these before we proceed. All right, so here we have a 3 by 3. Definitely pause the video, try to do this on your own, and then come back and join us again to make sure that you have the process down. But notice that if you've come back from your work, we have one polynomial written vertically like this. We have the other one written horizontally like this, with the terms separated within our table. Now we're just going to work it out just like a times table. So this times this will go here. This times that will go there. This times this will go here. This times this, for example, will go here. Just like a times table. So here we'll start here. Y squared times 3y squared. That's going to give us 3y to the 4. Y squared times negative 4y. That's going to give us negative 4y cubed. Y squared times negative 1 is going to give us negative y squared. Positive 5y times 3y squared is going to give us positive 15y y cubed. Positive 5y times negative 4y is going to go here, and it's going to be negative 20y squared. Positive 5y times negative 1 is going to be negative 5y. Negative 2 times 3y squared is going to give us negative 6y squared. Negative 2 times negative 4y is going to give us positive 8y. And negative 2 times negative 1 is going to give us positive 2. Always take a quick pause, check your multiplication. Since there are so many things that could go wrong, make sure you've done it right, then go ahead and combine your like terms. So again, real quickly, that's going to be 3y to the 4, negative 4y cubed, negative y squared, positive 15y cubed, negative 20y squared, negative 5y, negative 6y squared, positive 8y, and positive 2. So we're good to go. We're going to just go ahead and look at our groups of like terms. We see that we have 2 here, we have 3 here, and we have 2 more here. So, all right. So 3y to the 4 is not like anything else. So we're just going to write it. These two, so we have positive 15 and negative 4. That gives us positive 11y cubed. Here we have negative 6 and negative 20. That gives us negative 26, and then minus 1. This is one many people miss, so make sure you don't forget the invisible 1. All right, so we get negative 27 y squared. These two, you have 8 minus 5, so that's going to give us positive 3y, and then finally plus 2. Now, if you try to do this the standard horizontal way, your expression would be extremely long, etc. So this way, with the table, everything is nicely organized, and the like terms can easily be identified and combined. So highly recommended method. The safest thing to do in any class is to basically use the methods that your instructor takes the time to show you. They usually try to show you the most efficient methods, and that way there's no question about where the answer may come from. All right, so here we're going to handle one which has some fractions in it. So notice I left enough room for me to be able to do some multiplication within the boxes. We don't have to use the box for any of these, but it works out well. So here we're going to have 1/2 x times 1/3 x. So of course that's going to be 1/6 x squared. There was no cross-canceling possible, so we just get multiply cross. So 1 and then 6, so 1/6 x squared. Now we're going to multiply 1/2 x by negative 9/4 y. Let me put the negative 9/4 y first, just because it's negative. That way I can get away without using parentheses. So here like this, I notice there is no cross-canceling possible. So we're going to get minus 9/8 yx, or usually we like to write it as xy to respect the alphabetic order, but it's not important. You could have written yx, remember, by multiplicative commutativity, it would have been the same. So now we're going to multiply these two. So we have positive times positive is going to give us positive 2/3 y. Let me actually go ahead and write it out. So 1/3 x times 2/3 y. So we're going to get a positive result. No cross canceling, so that's going to be 2/9 xy. And now we're going to multiply these two. So positive 2/3 y times negative 9/4 y. So there is a little bit of cross canceling possible here. The 3 and the 9 are going to leave a 3. The 2 and the 4 are going to leave a 1 and a 2. Here we're left with a 1. Okay, so now we can see that positive times negative is going to give us overall a negative, and then 3/2 y squared. Okay, so now we're going to be combining the like terms, and these two are our only like terms. So let me go ahead and write it out here. So we get 1/6 x squared plus, I'm going to put the 2/9 minus 9/8 together like that, and then factor out that xy, and then minus 3/2 y squared. So now we get 1/6 x squared plus, we need to combine those two, and there is no they're not like fractions, so we need to find the common denominator. And of course, since the GCF of these two is 1, they have no common factor, right, other than 1. So the LCM is just going to be their product. So we get 72. So for 9, we have to multiply it by 8 to make it 72. So we have to do the same to the 2. For 8, we have to multiply it by 9 to make it 72. And we have to do the same with the 9. So on the top, we have 2 times 8, which is 16, minus 9 times 9, which is 81. And then this is going to be times xy minus 3/2 y squared. So let's take care of 16 minus 81. So let me just do 81 minus 16. We'll adjust the sign. 6 from 11 is 5, and 1 from 7 is 6. So we have 1/6 x squared. We're going to have the overall answer there will be plus negative 65/72 xy minus 3/2 y squared. While this is correct, it's not the simplest form of this. So we're just going to go ahead and multiply those two and write the answer in a nice, simpler manner like this. So we're just going to write the minus on the side there. 65/72 xy minus 3/2 y squared, like so. So notice that if 65/72 was possible to reduce, we would have done so, but they don't have any common factors, so that's not going to reduce any further. So this will be our final result. So no different from the ones with the whole numbers, with the exception that you have to take a little bit more care to make sure you don't make any careless errors. That's all. Otherwise, the procedure is exactly the same. And, you know, you have fractions, so if they're unlike, you know what to do. Just find the common denominator and handle it. So the thing is just not to create these zones of fear in your mind so that as soon as you see a fraction, you panic, because that right there is going to throw you off the track and cause you not to be able to finish the problem. But if you just take it, like, treat it like any other problem, you'll be fine. All right. So again, Write this out. If you haven't gotten that result on your own yet, write this on a piece of paper, go away from the screen, work it out on your own, then come and make sure you got this answer before you proceed. Remember, if you don't get it at first, go back and do it again. Again. You may be thinking, look, I don't have an infinite amount of time. I got things to take care of, etc., etc. So I can't spend that much time on one problem. But the point is, it's not going to take you that long forever. It's only going to take you that long if you have a lot of gaps in your understanding of mathematics from the past, and you need to fill those gaps. So during that period, which if you actually become real committed to doing this the proper way, shouldn't be all that long. It'll take you a little bit longer during that period. But once that's over, and what we call is you come up to par, meaning where you're supposed to be, then it's not going to take you as long to get to the right answers. So, but the point is not to give up. If you always seek help as soon as you run into a little problem in mathematics or in anything in life, honestly, then real progress is going to be almost impossible to achieve. So make sure that you don't give up if at first you don't get to the correct answer. All right, so here we have another problem, and one of the most common errors with this is to, of course, distribute this. And why can't you do that? Because of the order of operations. Remember the order of operations? Please excuse my dear Aunt Sally, right? Or PEMDAS. So the P stands for parentheses. It's actually better if it's G, because it's any grouping symbols. We need to take care of any operations within grouping symbols first. Here, there's nothing you can do inside. So you move on to E. That means you have to take care of exponentiation first before you go to multiplication. So this would be the violated law if you were to distribute the 3t squared. So because there's an exponent here, you have to go ahead and take care of the exponentiation here first, raising to that power, before you multiply the 3 squared. So the 3t squared. So here's what we're going to do. We're going to write 3t squared, and here we're just going to write t minus 2 times t minus 2. Now, we know how to handle t minus 2 times t minus 2 very quickly. So we have t minus 2 and then t minus 2. So we just make a table and we just go ahead and multiply it out. So here we have t squared minus 2t, and minus 2 times t gives us minus 2t again. And these two will give us plus 4. So we can see that we have t squared minus 4t plus 4, right? So now we go back up here, we rewrite the 3t squared, and for t minus 2 times t minus 2, well, we just work that out here, remember? So we just get this. So we write that right here. I'm sorry. T squared minus 4t plus 4. Now all we have to do is go ahead and now distribute the 3t squared. Not before this point, but now there's no more outer power to deal with. So we go ahead and distribute, and there's nothing you can do inside. We've already taken care of the combining of the like terms. So now we distribute. So we get 3t to the 4 minus, see, positive times negative, that's negative. 3 times 4 is what? 12. And t squared times t, remember, that's t squared times t to the 1. So t to the 2 plus 1. So t what? Cubed. So 12t cubed. And then plus 12t squared. So that would be our final result here for the product. All right, again, simple, but you got to make sure that you know how to do it and handle it on your own before we proceed. All right, finally for the day, we're going to look at what is known as FOIL. It's actually going to play a bigger role later when we do factoring, meaning the opposite process of multiplying, than it will now, but we'll go ahead and introduce it here, and we'll use it extensively later as well. So let's just say we want to multiply these two polynomials. So we know that we have to distribute the x, right? So we get x times x, and then x times 3, right? And then we distribute the 2. So 2 times x, and then 2 times 3. So notice this right here, the product of the first term here and the first term here, we call f. The product of capital F, right? The product of the first term, the last term here and the last term here, notice that's indicated by L. This product in here, we call that the inner product, and this one here, we call it the outer product. So that's where the acronym FOIL comes from, F-O-I-L. So we can always multiply these by taking care of first times first, so that's where that goes, and then O, which meaning the outer, right? And then I, which is the inner product, and then the last times last, so L, and we get this. Again, like I said, there's not a huge concern about anything special about this, except that when we do factoring later, we'll want to go work our way backwards, and that's going to be very helpful. All right, so of course, remember, it makes this nice happy face. Okay, so FOIL, and let's go ahead and do one more problem using this technique. So we have x minus 5 times x plus 3. So remember, we're going to use FOIL. So the first thing we'll do is we'll take care of the f, which is first times first. So we write x squared. Then we do the outer, so that's going to be the x times the positive 3, so plus 3x. Then we do the inner product, which is going to be this, which is what? Negative 5x. And then the L, which is the last term times the last term. So negative 5 times positive 3 is negative 15. So we get x squared minus 2x minus 15. So of course, we could have gotten that from our table as well. So it's not an indispensable skill, but it's really good to have for what you will see coming soon. So x squared plus 3x minus 5x minus 15, combine those to get the negative 2x, and we get this result. All right, so that's called FOIL, or the operation is called foiling. All right, so that should do it for this video. Make sure you can handle all the topics before you attack your homework, and you should be in great shape. So stay safe until our next video.